So we now consider a two charge system Q1 and Q2. The charge Q1 is fixed at the point A and the charge Q2 is moved from the point B to point C along the line ABC. The distance AB is R1 vector and the distance AC is R2. And now at some instant the charge Q2 is from the distance R from Q1. So the force from the Coulomb's law, the force is Q1 Q2 by 4 pi epsilon naught R square acting along the AB vector. So if the charge Q2 is moved by a small amount dr, so the work done dW is equals to F dot dr, that is Q1 Q2 by 4 pi epsilon naught R square dr. So the total work done to move Q2 from R1 to R2 is W is equals to integration dW, that is Q1 Q2 by 4 pi epsilon naught to integration R1 to R2 dr by R square. Okay, so this will become that Q1 Q2 by 4 pi epsilon naught into 1 by R1 by 1 by R2. So this is the work done to move the charge Q2 from R1 to R2. So if and we know, we have considered that the charge Q1 is fixed at the point A, so there is no work is done on the charge Q1. So the change in potential energy is U R2 minus U R1, that is equals to the minus of the work done, negative of the work done, that is Q1 Q2 by 4 pi epsilon naught 1 by R2 minus 1 by R1. So negative of this. So if the separation between the two charges are infinite, okay, so the separation between the charges are infinite, so the potential energy U should be minus of, if the R1 is infinite, then we can say that this is Q1 Q2 by 4 pi epsilon naught to 1 by R minus 1 by infinite, that is Q1 Q2 by 4 pi epsilon naught R. So this is the potential due to potential energy due to two charges. Okay, so the potential energy depends essentially on the distance between the two charges, not the location of the charge. Now we consider a charge, again we consider a test charge small q. Okay, again we consider a test charge small q is moving along an electric field E. Electric field is E and it is moving. So the test charge, if the test charge q is moving from one point to the another, so the potential difference VB minus VA, potential difference VB minus VA will be the potential energy UB minus UA, the potential energy between the 2 points divided by the charge. So conversely, we can say that if a test charge moves along a potential difference, the potential of the 2 points changes by this. Okay. So we can define the absolute electric potential at any point by choosing a reference point by saying that the potential at this point is 0. So we can say that VA is equals to VA minus VP, that is UA minus UP by Q. So the potential at a point A is equal to the change. So potential is equal to the change in potential energy per unit test charge. Unit test charge. Okay, suppose the test charge is moved along the electric field without changing its kinetic energy. So kinetic energy is not changed. So according to the work energy theorem, the work done by the external agent plus the work done by the electric force should be 0. So we can say that work done by the external agent should be the negative of the electric work done of the electric force, work done by the electric field, and this is the minus of, we can say the minus of delta U, that is the change in potential energy, change in the potential energy. So this is the reason why the work done is the negative of the potential energy. Work done is the negative of the potential energy.